Hello. Okay, so today we're going to talk about graphing linear inequalities. So really what we're going to do is put together our knowledge about graphing lines and then our knowledge about inequalities and put them together. Okay, so our learning target is to be able to graph a linear inequality on a coordinate plane. Excuse me. Okay, so I want you to take a look at this picture. The answer is correct, but how? We'll pause here. All right, how do I graph linear inequalities? Before we get into linear inequalities, let's talk about inequalities in one variable. So this first one says graph x is greater than or equal to 5. So here's 5 right here, okay? And we want to say all the numbers greater than 5, but also include 5. So the way that we did that was, in order to include the 5, we would do a closed dot at 5. And then we would say everything greater than 5 would be everything this way. So we would shade everything bigger than 5. But that includes 5, okay? Now, if we want to graph this says x is greater than 5. It doesn't say greater than or equal to 5. So when we do this, we would say, all right, how does this work? Well, here at 5, if you put a 5 here, 5 is not bigger than 5. In other words, 5 is not greater than 5. That's a false statement. So we don't want to include 5. We want anything bigger than 5 to be included, but not 5. So then what we did was we just took and we did an open circle here to say right at 5 we're not going to include that, but then anything above that we will include. So we did that, an open circle, to represent that. So that was the difference. The only difference between x is greater than or equal to 5 and x is greater than 5 is one number, and that happens to be 5. And we used an open or closed dot to represent the difference there. Okay, so we're going to be graphing two variables, which will be lines then, and we need to come up with a way to be able to represent the difference between these two as well. All right, what is a linear inequality? It simply relates two variables using an inequality. So for example, like y is greater than 2x minus 4. So y is greater than 2x minus 4 would be all of these points here in the blue shaded region, and it would not include this red line. That's the boundary line. So we would draw that line, but we want a way to signify that that's not included. Only the blue section would be included. Now, if it was greater than or equal to, then we'd want that red line included, because this is where that boundary line, notice where right here, this is where the line y equals 2x minus 4. So if we have y is greater than or equal to, then we want to include that red line, okay? So that's called a boundary line. It cuts it into two regions. All right, so we have our symbols here, right? Greater than, less than, and then greater than or equal to, and less than or equal to. So how are we going to determine what we do? If the boundary line is included, we don't want to include that. So how do we signify that? Before, if we had one variable, we just used an open dot, okay? Here, what we're going to do, if it's greater than or less than, then you can see there's no or equal to. So that equals line, that boundary line will not be included. So then what you're going to do to indicate that it's not included is you're going to do a dashed line. Okay, so you'll draw your line. It'll look maybe like that. Okay. Now, if the boundary line is included, in other words, greater than or equal to, or less than or equal to, so it's got the or equal to, so that means we want to keep that line as a part of the solution set, then you're going to do a solid line. Okay, so it'll just be like normal. Okay, that means all the points on that line are also included. Okay, and then you will figure out which way you need to shade. Okay, as a quick review, we have 4 types of lines that we have talked about. Slope-intercept form. To graph lines in slope-intercept form, you want to start here with your y-intercept on the plot that, and then you're going to do the slope next, okay? Rise over run. If it's in standard form, you are going to use the cover-up method, okay? And that will give you your x and y intercepts, all right? If it's a line like y equals b, then like y equals 5, you know that that's a horizontal line, okay? If it's x equals a number, you know that's a vertical line. So these are the 4 lines we've already talked about how to graph, and now what we're going to do is there's going to be an inequality there instead of an equal sign. So how does this work? All right. So first you're going to graph the boundary line. So you're going to pretend like this is an equal sign to start, okay? So now notice this is really in y equals mx plus b form. So as a reminder, when we start with these, we start with the y-intercept. I want to plot this first on the y-axis. So my y-intercept is 2. I'm going to make a dot right there, okay? And then this is my slope. So I'm going to say -1 over 3. So that's a rise over run. So this would mean down 1 to the right 3. Rise over run. So where I started from was 2 on the y-axis. Now I'm going to go from there. So that's your starting spot. Your y-intercept is always your starting spot. You're going to go down 1 and then 1, 2, 3 units to the right. Okay? So my other point will be right here. And now I'm going to draw my line through there. Okay? Now, that's my boundary line. Now notice it says greater than, okay? And we just said on the previous slide that if it's greater than, we don't want all this orange line is where y is equal to -1/3 x plus 2. Well, we don't want to include all of those, so we need to make this a dashed line. So what I'm going to do is I'm just going to use my eraser here. I want to make this dashed. You can do this different ways, but that's how I generally do it. So now that means all those points on the orange line are not included. Okay, so now the next thing is I want to figure out which way to shade. Oops, sorry about that. Which way to shade. And in order to do that, I need to make my eraser a little bit bigger here. In order to do that, I kind of put this at the bottom. You want to use a test point 0, 0 to see which one it is. So it says greater than. You would think, oh, well, maybe that's up, but you want to be sure. So really what you do is you put in this test point 0, 0, and I'm going to, so 0, 0 is right here. Now, if we shade this way, then 0, 0 would be in the solution region and it should be a true statement. Okay? If we shaded this way, then 0, 0 would not be in the solution region and it would be a false statement. Okay, so really what we're going to do is we're going to test it. We're going to put a 0 here. Oops. -1/3 times 0 plus 2. So really this gives us 0. -1/3 times 0 is 0. Plus 2 is 2. So is 0 greater than 2? No, that's a false statement. So 0, 0 is not in the solution region. That means I need to shade this side. If it were true, we'd want 0, 0 to be in the solution region, so we'd shade the other side. So really my solution region is anything that's in the yellow area here, okay? All right, so that's graphing an inequality. Okay, so now let's try another one. All right, so this is another one that says, but the x and y are on the same side. This is in standard form. So again, you're going to do the cover-up method. So if I cover this up, I'm going to cover this up and really just pretend like This is equal sign for now. And so if I do that, I get -4. Now remember, this is my x-intercept. Okay, so I'm going to plot -4 on my x-axis. Okay. Now, next, I'm going to cover up this and pretend like that's an equal sign for now. Divide by 6, I would get -2. And remember, this is my y-intercept. So I'm going to plot that on my y-axis. Okay. I'll erase this here. Okay, now it says 3x plus 6y is less than or equal to -12. So or equal to, that means the boundary line is included. So this should be a solid line. I'm going to draw a solid line through these 2 points. Okay. All right. And now I have to figure out which way to shade. So what I'm going to do, I'm going to erase this here, is again use 0, 0 as a test point. 0, 0 is right here. So if it works, we would shade the side 0, 0 is on. If it doesn't work, we would shade the other side. Okay, so if I use 0, 0, 0 for x, 0 for y, so that would be 3 times 0 plus 6 times 0 is less than or equal to -12. So really this is going to be 0 on this side. Okay, is 0 less than -12? No, actually -12 is smaller than 0, right? So this is also a false statement. Okay, so what that means is I'm going to shade away from 0, 0. 0, 0 is up on the top side there, so we're going to shade. We're going to shade this side. So again, if it's a true statement, shade the side 0, 0 is on. If it's a false statement, shade the other side. Okay, and then lastly, graph the inequality. These ones are kind of nice. So you look at this and you go, oh, y equals -5 is a horizontal line at -5. Okay. Now, it says y, it doesn't say this. This is where everything is y equals -5. It says y is greater than -5. So I need my eraser again, and I want to make this a dashed line. I don't want those points included. It's everything greater than -5. Now, everything greater than -5, you don't necessarily need to use a test point for this one. Everything greater than would be everything above. So I would shade 0, 0. The side 0, 0 is on. But again, if you don't want to look at that. If you're not sure, you can use 0, 0. Here's how it would work. 0, 0. There's no x to plug in, so I would only be plugging in for y. So I would get, is 0 greater than -5? Yes, it is. That's a true statement. So here's 0, 0. We want that to be in the solution region, so we would shade the side 0, 0's on, which is what I did. Okay? That is how you graph inequalities. Okay? All right. So now what I'd like you to do is work on graphing linear inequalities assignment. Hope this makes sense. Good luck.